Good evening, YouTube. So the next step is I want to increase the output of this burner, which is the semi-rapid or SR size. Now this came with a 0.65 millimeter, but with that size and 10-inch water column gas pressure, that's just short of 4,300 BTU per hour. So what I've done is I've taken the 0.65 and I've moved it over here, and I showed you that in an earlier video. Now what I've done is I've taken the 0.5 that used to be here and I drilled it out to 0.7 millimeter and put it in here. So that should give me about 5,000 BTUs. So let's see what that looks like. Yeah, that looks pretty close to the original 0.65, so I just wanted to look at the 0.7, that way I can see what it looks like there in the video. So this is 0.7 millimeter with propane at 10-inch water column. Okay, we got the burner apart. Here's the jet, or injector as they call them in Europe. So this is currently 0.7 millimeter, and I have a 0.8 millimeter drill there. There we go. Run the bit through until it's nice and free, and you want to make sure you get all the shavings out before you put it back in there. Let's see. This one's a little easier to work on because you can get your finger down inside. But there you go. So now we've got 0.8 millimeter. So I guess this is called the burner body. This is the burner head. This is your burner top or flame spreader, and then this is your spark igniter. So there we go. You can see the little spark jumping in here, and there's a little passage here that lets the gas that comes up out of the jet comes up through this hole. A little bit of gas leaks out here, and then the spark jumps from the igniter over to the burner head and lights your gas, and then that catches the rest of the burner on fire. So this should be around 6,500 BTUs. I'll have to check that on my table. So yeah, that's looking pretty good. So that's pretty close to the rated output power. Let me put a pot of water on there and maybe we can do a time to boil test. Okay, time for a boil test. So that 636 was the time to boil with the 1 millimeter orifice. So now I've got 0.8 millimeter. So let me reset. We're on max flame and we'll start. Yeah, you can see that's a pretty good sized flame under there. Pretty much covers that bottom of that teapot. It's about 7 minutes and 50 seconds, maybe 7:45 when it started boiling. See if that turns down. There's a simmer. Yeah, I like how the heat just instantly changes. I just turned it down to simmer and it stopped. And then you turn it up and it starts boiling again. And so that was about 1 minute and 15 seconds slower than the 1 millimeter. I do like the controllability here. So that's one of the reasons that I understand that they make these different size burners, because a gas burner, if it's sized right, has about a 3-to-1 ratio. So the smaller burner over here goes from 1 kilowatt down to, say, 300 watts. This one might go from 1800 down to 600. And the problem is, if the 600 is too hot, you have to move it to a smaller burner. So that's why they do the auxiliary or simmering burner. This is what they call the semi-rapid, and then some of the bigger cooktops have a larger 3 kilowatt burner that they call the rapid burner. So you bring your pot to a boil on the big burner and then you move it to the small burner to simmer. So let's take a look at the flame in the dark. So there's the low. So you get a fair degree of control. You can go down, 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 down. So that's pretty darn low right there. So the small burner has the jet that used to be in here is now over there. And the one in the small burner has been drilled out from 5/10 to 8/10 of a millimeter. But yeah, I think that's a pretty good result there. And one of the reasons I want the flame a little bit bigger is my soup pot actually is about this big. It comes out here clear to the edge of the cooktop. Having a bigger flame gets more heat on the bottom of the pot. Since that's what I plan on using this quite a bit for, is if I can do my 2 hours of cooking out here and I'm not heating up the kitchen on a hot summer day, I'd rather be out here. The propane side will be done, and then I'm going to switch these back to natural gas. On the natural gas, I think this one is good with the 1 millimeter jet, and then I just need to size this one. So the idea is I want to have my boil time on propane, and then I'll make the natural gas jet the same heat output so that I get the same boiling time on natural gas. So that's why I'm trying to do the propane first, because it's smaller orifice diameter, so I can use the smaller orifice jets that I have, enlarge them, get that dialed in, because then when I go to the natural gas, I got to start with the big orifice and make it bigger. Because once I finish with the propane jets are going in a little bag or a little plastic box, you know, maybe even tape the things to the bottom of the sink or something, just so they're here if I ever need them. And that's why I also wanted to do that now, because if I have to switch back to propane, I just want to be able to pull out the 2 screws, change that one, pull out those 2 screws, change that one. I can flip the regulator over and hook up my gas bottle, and I'm up and running. I don't want to have to fool around with drilling holes, finding my drill bits, and yeah, if anybody, especially in Europe, knows anything about these gas burners and why they use the size orifices that they do, because everything I find, they always put a 0.5 millimeter in the small burner. If it's a 1.7, 1.8 kilowatt burner, they put a 0.65 in there. If it's a larger, like a 2 kilowatt burner, they'll put about a 0.7. But that is undersized. It's not putting out the rated output. It's really a false economy. You know, you can do your marketing and say, hey, we use less gas, but it's going to take you a lot more time to cook your food, and you're going to burn more gas in the long run because of that. So I think people would rather have a stove that cooks quickly and then they're done and they turn the gas off, because if this is off, it's using nothing. If it's on but takes twice as long, it's going to use more gas in the long run. So anyway, I'll try to cover that in a separate video. So yeah, if you have any questions about that, post up in the comment section below. And as always, thanks for watching.